Hello everyone, welcome back to our chemistry class. We are still in 2.3 electronic configuration part C. So in this video, we will be talking about electronic configuration of monoatomic ion. So before we start, let's take a look what is valence electron. So valence electron is the electron in the outermost shell of atom. So for an example there, we are given natrium atom with proton number 11. So the electronic configuration is 1s2, 2s2, 2p6 and 3s1. So to determine the valence electron, we draw a border between the shell, okay, and the last shell there is 3s1. Therefore 3s1 is the valence electron shell. So the valence electron for sodium atom is 1. Next example is chlorine. So the electronic configuration for chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. Okay, and then we draw the border between the shell. Okay, so when we draw the border, we have the valence electron shell there, which is 3s2, 3p5. Therefore, the total number of valence electron is 2 plus 5, which is 7. Next, we have titanium. So the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d3. So this is a special case because bila mana kamu buat dia punya electronic configuration dan dia sudah tercapai pada energy level 4, okay, ada satu step tambahan yang kamu kena buat, which is you need to rearrange the electronic configuration. So bila you rearrange, you get 1s2, 2s2, 2p6, 3s2, 3p6, 3d3, 4s2. So selepas rearrange, baru kita buat dia punya border. So as you can see dia, ini adalah special case. Kenapa? Kita akan bincang dalam next chapter. So kalau border itu di antara 3d3 dan 4s2, meaning to say, okay, dia dahsyat, okay, D dengan S, meaning to say that is the valence electron shell. Okay, therefore the number of valence electron is 3 plus 2 equals to 5. And the last example for gallium. So the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 and 4p1. Like I said before, when your electronic configuration is reaching energy level 4, there is one extra step that you need to do, that you need to rearrange the electronic configuration. So when you rearrange, you can get 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2 and 4p1. Then only you can draw the border between the energy level. And after you draw the border, you can see there the valence electron shell is 4s2, 4p1. Therefore, the valence electron is equal to 3. Now let's discuss how can we write the electronic configuration for monoatomic ions. So the tips number 1 that you must always remember, you must write the electronic configuration for the atom first, and then only you can write the electronic configuration for the anions and also for the cations. So for anion, you will add electron into available orbital with lowest energy first, while for cation, you will remove electron from orbital with the highest energy first. Remember, for the electron in 4s and 3d orbital, electron from 4s will be removed first because 4s have a higher energy than 3d. Why is this? Okay, because when we assign electron into empty orbitals, energy in 4s is lower than 3d. But when removing electron from a filled orbital, energy in 4s is higher than 3d. Ceritanya begini begitu guys. Kalau dia kosong, okay, 4s dengan 3d itu kosong, 4s dia punya energy lower daripada 3d. Tapi bila 4s dengan 3d ini ada isi elektron, okay, 4s akan jadi higher energy level compared to 3d. So let's take a look at example 8. You were asked to draw the orbital diagram of the electronic configuration for sodium, and then you were asked to write the SPDF notation for sodium atom and sodium ion. So there is a total of 3 things that you need to do here. So the first one, draw orbital diagram, and then the second one, you need to write the SPDF notation for sodium and also sodium ion. So kita draw orbital diagram first. Okay, you can use either boxes ataupun platform punya type, and then don't forget to label each of the orbital. And then when you fill the electron into the orbital, don't forget to use the Aufbau, the Hans and the Pauli exclusion principle. Okay, lepas tu orbital yang tak terisi tu kita padam lah. So the electronic configuration for sodium atom is 1s2, 2s2, 2p6, 3s1. Okay, and then what we do, we draw the border between the energy level between the shell. So we can see there 3s1 is the valence electron shell. So meaning to say the valence electron is equals to 1. Okay, so kita tahu atom ini untuk capai oktet dia perlu ada 8 elektron. So untuk sodium capai oktet, mana yang lebih senang? We add 7 elektron ataupun we remove 1 elektron? Yang mana sebaik-baiknya kita remove 1 elektron. So the electronic configuration for the sodium ion, okay, is equals to 1s2, 2s2, 2p6, yang mana kita remove 1 electron from the valence electron shell. Jadi bila kita remove, kita akan dapat positively charged ion. Next, for example 9, same thing, you were asked to draw the orbital diagram of the electronic configuration of chlorine and then write the SPDF notation for chlorine atom and chlorine ion. So chlorine punya orbital diagram kali ini kita guna platform punya type. So kita bikin dulu dia punya tapak, and then after that we fill in electron accordingly to Aufbau principle, Hans rule dan juga Pauli exclusion principle. Okay, so the electronic configuration for chlorine is 1s2, 2s2, 2p6, 3s2 and 3p5. So for chlorine ion, because it is negatively charged, so we need to add electron into available orbital with lowest energy first. So we draw the border between the shell, so we can see there the valence electron shell is 3s2, 3p5, therefore the valence electron is in total of 7. Okay, for atom to be octet, they need to have 8 electron. So we must plus 1 lah to the lowest energy orbital yang available. So the electronic configuration for chlorine ion is 1s2, 2s2, 2p6, 3s2, 3p6. Example 10 is a bit different because you were asked to write the SPDF notation for calcium and its more stable ion. So dia tidak bagi tahu kamu apa charge untuk tu ion. So you need to figure it out. So the first thing that you must do, you need to write the SPDF notation, the electronic configuration for the atom first. Okay, so bila sudah right, apa yang kamu kena buat? Kamu kena draw border between the energy level. So as you can see there, the valence electron shell is 4s2, so meaning to say the valence electron is equals to 2. Okay, so for an atom to be octet, okay, it must have 8 valence electron. So mana yang lagi senang, kita tambah 6 elektron ataupun kita remove 2 elektron? So kita akan remove 2 elektron. Okay, so bila kita remove 2 elektron, meaning to say the ion that will be formed is positively charged ion, and the SPDF notation is 1s2, 2s2, 2p6, 3s2 and 3p6. Just a reminder guys, when you remove 2 electron, meaning to say the charge of your ion is 2+. Kalau kamu remove 1 elektron, charge kamu punya ion adalah 1+. Sama juga kalau kamu add in 1 elektron, charge ion itu akan jadi negatif. Dan kalau kamu add in 2 elektron, charge ion tersebut akan jadi 2 negatif. So I want you to do it by yourself for example 11. So that's all for this video. Okay, I hope you can really understand how to write the electronic configuration for monoatomic ions. I'll see you in the next video. Bye bye and thank you guys.